Hey, Kayla.
Sorry, my phone was muted. Oh my
Oh, you're
gosh.
fine. Okay, today we're going to do 3.3 and 3.4. So 3.3, so we started talking about graphing lines on Tuesday. So 3.3 is going to be talking about the slope of the line, how slanted it is or how steep it is. Okay, the first few problems are recognizing by looking at a line whether its slope is positive, negative, 0, or what's called undefined. So I'm just going to write up here those 4 different kinds of slopes. All right, so those are the 4 different kinds of lines we're going to be looking at when we're trying to figure out if slopes are positive, negative, 0, or undefined. Okay, you can kind of read each one of these graphs like a book, like you would the pages in a book, from the left side to the right side. Okay, so if I'm reading this like a book from the left side of the graph to the right side of the graph, and the line is traveling up from the left to the right, that's going to be a positive slope. The slope of that line will be a positive number. Okay, this one, again, reading it from the left side to the right side. If you're traveling down, starting from the left, traveling down to the right, that slope will be a negative number. Okay, now these 2 lines, horizontal and vertical, they aren't going up or down. Well, I shouldn't say this. They aren't slanted like these positive and negative slopes. They each have their own slope. Okay, if you are a horizontal line like this one, your slope is 0. The slope of all horizontal lines are 0. If you're a vertical line like this one, this slope is called undefined, and we'll see why here in a little bit. That's called an undefined slope. Okay, so you're either positive, negative, 0, or undefined. So we're going to use this guide here to help us with the first few problems on 3.3. Okay, all right. Well, here, I'm going to do them each separately. Okay, on number 1, it's asking me 2 things. Okay, it gives me a graph. It gives me a line that looks like this. It's going to ask you 2 things. It's going to ask you, is the slope positive, negative, or 0? And the value of the y-intercept is positive, negative, or 0. So again, let's do the slope first. So again, reading it like a book, from the left side to the right side, this red line is traveling up from the left to the right, which means the slope of that line is positive. Now, let's talk about what the y-intercept means. We did talk about this on Tuesday. The y-intercept of the graph of the red line is where it crosses through the y-axis. If this is my y-axis, here is the 0 of the y-axis, that very middle spot. All the numbers that are above this middle, which is called the origin, are positive, right? The positive numbers of the y go up here. Below this 0, they go negative. So all it's asking you, it's not asking you for the exact y-intercept, it's just asking you if it's positive, negative, or 0. So if 0 is right here and it crosses the y-axis above that, then that just means your y-intercept is positive. Okay, let's look at number 2. Okay, number 2 looks like this. Should have given you some more variation on these, because what is this one also? It's almost exactly like the first one, right? It's slope. Since it's from the left side to the right side traveling up, its slope is positive. And once again, where is it crossing the y-axis? Here's my y, and here's where it crosses it. Since it crosses it above 0, that means the y-intercept is also positive. All right, number 3. Number 3, this one's different, right? Its slope is something different. It's a horizontal line, the one that goes straight across. And all slopes of horizontal lines are the number 0. The y-intercept. Here's my 0 on the y-axis. Since the red line crosses above it, that just means its y-intercept is positive. Okay, I'm going to do another one up here just to give you an example of what it looks like with the negative situation, since there weren't any, but you could possibly be given some. So if you had one that looked like this, so again, reading it like a book from the left side to the right side, this one starts at the top and travels down. So that's what it's going to look like if your slope is negative. The y-intercept, okay, here's my 0 right there in the middle. This time the red line crosses it below that 0, which means the y-intercept on this one is also negative. Now it is possible they don't have, these two things aren't necessarily always the same. What if you had the red line look like this? This one. The slope would still be negative, right? Because it's starting at the top and traveling down. But this one's y-intercept would be positive since it crosses through the y-axis above the 0. So these two things aren't necessarily always the same. Okay, so that's the first thing we're going to do with slope. This next part what we're going to do is learn different ways to find the slope depending on the information that you are given. Sometimes you're given an equation, sometimes you're given 2 points, sometimes you're just given a picture. The first ones are giving us a picture. Sometimes you will hear the slope called the rise over the run. Because what it's telling you is what's happening in between points. For instance, if you have a line like this, if there's a point here and a point here, to get from one point to the other, I have to rise and then run. So that's what that rise over run is telling you. What's happening in between points? How far am I going to have to rise and run to get from one point to the other? Okay, on number 4, it gives you the picture of a house with a roof. And asks you to find the pitch of the roof, which is the slope, which is how the pitch of the roof is this right here. How slanted is it? How far is it rising and running? So just make sure you put the right number on top and the right number on bottom. The top number has to be your rise, which is how far it's going up and down. So my rise would be 28. My run would be this distance, which is 32, but then you have to be careful because it says type an integer or a simplified fraction. So remember how to do that in your calculator. If you're not sure, if that is simplified, just type it in your calculator. 28 divided by 32. Now remember, when you hit enter, it's going to give you a decimal. So we just enter that to get the simplified fraction. So it does reduce to 7/8. Okay? All right, number 5. This one gives us the picture of a slide, right? The slide is going to have a slope. So it's going to have a rise over a run. So you'll notice, look at the direction of this slope. Starting from the left, going to the right, it's going down. That's what's going to make it have that negative slope. So it's saying to get from this point to this point, I would have to go down 10, which means that's why the rise is negative. So rise down 10 and then run 14. Okay, so here's your rise number, so that'd be negative 10. Your run number would be 14. And then just use your math enter. So negative 10 divided by 14. Get your decimal by hitting enter, then hit your math button, and then hit enter twice to reduce that fraction to negative 5/7. All right, number 6. Just gives us another picture. It's not the picture of anything in real life. It's just a picture of a line, but it's a special kind of line. It's one of those kind of lines, which is horizontal. So since it is a horizontal line, all horizontal lines have the same slope. Their slope is 0. So when you type that answer in, it's a multiple choice here. You have choice A or choice B. The slope of the line is blank, or the slope of the line is undefined. 0 does not mean undefined. You just type in the number 0 right there in that blank. Undefined, this one would be undefined. From the beginning of class, if this is what the slope looked like, that answer would be the B answer on your multiple choice. This one would be undefined. So horizontal, the slope is the number 0. Vertical, the slope is called undefined. Okay, so that's the rise over the run. So if it gives us a picture and tells us what the rise is and what the run is, we just enter that as a fraction and then simplify it. Okay, now another method, sometimes it doesn't give you a picture, it doesn't tell you the rise and the run, it gives you 2 points that are on the line. So that's called the slope formula. I'll let y'all write that down. Okay, so the slope formula, this says slope equals, the little lowercase m stands for slope. Y2 minus y1 over x2 minus x1. I'm going to do a couple of them before we get to the actual problems on the homework, because the problems on the homework throws in a bunch of ways to make sign mistakes. So let's just get practice first using this formula. So there's the formula, y2 minus y1 over x2 minus x1. So let's say the question says, to find the slope of the line that passes through these 2 points. Now, I'm going to show you something that hopefully, the main thing that happens here is people just put stuff in the wrong spot. Okay, so remember, if you are a point, that you have an ordered pair, right? And every single ordered pair has coordinate. The first number is your x, the second number is your y. So if this is a point, it's got its own x and y. If this is a point, it's got its own x and y. Now what we're going to do is just label each point as being the first point and the second point. And it doesn't even really matter which point you label as first or second. So if I always just call this one on the first one my first one. So if it's the first point, it's going to be having the ones. If it's the second point, it's going to have the twos. Here's what can't happen. You can't have one point have a 1 and a 2. That's where you'll get mixed up. Okay? So again, give each point an x and a y. And then label one with the ones and the other one with the twos, and then plug into the slope formula. So let's see. M is going to equal, the first thing I need in my slope formula is my second y. So now all you're doing is just going to find the number that's in the second y spot, which is the number 8. Now, something else that's important, you always put a minus. It's always minus from the formula. And then after the minus, you have your y1, or your first y. So my first y is the 3. So there's the top of the formula. The bottom of the formula is going to do the same thing, just with the x's. Okay, so the first thing I need is my second x. So my second x would be 5. Then again, minus my first x. Here's my first x, which is the number 2. And then after you plug in, you're just going to do the math on top and bottom. So up top, let's see, I've got 8 minus 3, which gives me 5. Down low, I have 5 minus 2, which is 3, and that's your slope. You would simplify it if it's simplified. It's just that 5/3 doesn't simplify. Okay, I'm actually going to do another one before we go to number 7. Actually, let's do 7 and 8 flip-flopped. 8 doesn't have as much signage stuff, so we'll do number 8 first. So on number 8, it says find the slope, if it exists, of the line containing the pair of points. My points are at 9, 4, and 10, -6. So again, before you go and start trying to plug numbers into the formula, label. It takes a little bit of time on the front end, but it saves a lot of mistakes. So again, each point has an x coordinate and a y coordinate. So give it an x and a y. And then label. There's my first point, so I'll give it the 1s. Here's my second point, so I'll give it the 2s. Now plug in. So your slope is going to equal, again, the first thing up top is your second y. Well, my second y is -6. Then minus, that's the formula. Then your first y. So my first y is 4. And do the same thing in the bottom. Let's see, the first thing I need is my second x. My second x is 10. Minus, just go ahead and put that minus in because it's always there. My first x is 9. So let's see what we have here. If you're not comfortable, remember, use your calculator. -6 minus 4 gives me -10. Down here, I have 10 minus 9, which is 1. Now, I like this answer But it's going to say simplify your answer because negative 10 over 1 will simplify to just negative 10, right? Okay. I actually kind of like this answer because when you're talking about the slope, these two things are telling a story about the line. This says the rise would be negative 10 and the run would be 1. So even though Math Lab doesn't like that, it only likes that. In real life, this number down here, usually you don't want to see it as a 1 in the denominator, but the 1 in the denominator of a slope tells a story. It tells the run number. Okay, now let's go back to number 7. Here is where we're going to have to really focus on our signs and our sign rules. So there's my 2 points. It wants to know the slope of this line. So let's again label everybody first on the front end. Don't try to start. You'll get confused if you just try to start plugging things in without everybody having their labels. So I've given each point an X and a Y. Since this is my first point, I'll call it the 1s, and then there's my 2s. Now, be careful when you are plugging in here. What do I need first? I need my second Y. Well, my second Y is negative 17. Go ahead and put your minus, right? Because that's part of the formula. What comes after the minus? Your first Y. Well, my first Y is negative 12. So here's where it can get confusing because right here you're going to have minus and negative. But that's just what it is, right? Because you have the minus that comes from the slope formula. But when you plugged in your first Y, it was negative 12. So it looks funny. So let's do the bottom. I need my second X. My second X is negative 13. Minus, right? Go ahead and put it in. My first X. My first X, again, there's another negative 5. So let's see. I can actually plug this in just like it's showing. Okay? I'm going to do the top first. So if I'm plugging that in, type it in exactly like you see it. So the first thing you need is the negative, which is the button below the 3. Negative, what do I need? Negative 17. Then hit minus, right? Because you want to subtract. But then what are you subtracting? Negative 12. So don't put minus, minus. That's going to give you an error. You're not minusing a minus. You're minusing a negative 12. So you've got the minus. Now, the negative button again for negative 12. So negative 17 minus negative 12. Hit enter. So there's what the top is. And then do the bottom. Same thing. Negative 13. Then your minus. Then I'm minusing negative 5. So negative 13 minus negative 5 gives me negative 8. So 5/8 doesn't reduce, but it is a negative over a negative, which actually turns that into positive 5/8. So you just have to be really careful with your signs here. I'm going to put one on the board just to give y'all a practice with some. All right, let's try this one. Here's an X and a Y. There's an X and a Y. Here's my first point, so I'll give that first point the 1s and my second point the 2s, and then plug it into the formula. So up top, I need my second y. So my second y will be 5. Minus, right? Go ahead and put the minus in. Then minus my first y. And my first y is -1. So I should have 5 minus -1 up top. Then the bottom, my second x would be -6 minus my first x would be -7. And then I'll type that in my calculator. So up top, I have 5 minus, right? Hit the minus button, then the negative button. So minus -1 gives me +6. -6 minus -7. So what is that going to give me? Let's see. -6, then your minus, and then -7 gives me 1. So I've got 6 over 1. If I simplify that, it just gives me 6. Okay, let's go on to number 9. It's another one. 6, 10, -3, 10. So here's an x and a y. Here's an x and a y. First point gets the 1s, second point gets the 2s. So let's see. Up top, I need my second y, which is 10, minus my first y, which is 10. In the bottom, I need my second x, which is -3, minus my first x, which is 6. Look what you get up top. You've got 10 minus 10, which gives me 0, which actually means it doesn't even really matter what the bottom number is. Because if you have a 0 as your numerator, 0 over anything is always 0. So the slope of that line would be 0. So let's see, -3 minus 6, just for fun, will give me -9. But again, it doesn't matter because 0 over anything is 0. And remember, what kind of lines have that slope of 0? The horizontal lines. This is why the slope is 0, because if you do the y's in the top and subtract them, you're going to get a 0. I'm going to plot these 2 points. It doesn't ask you to do that, but I just kind of want to tie it in together to show you why the slope of a horizontal line is really 0. So let's see if I plot these 2 points on a graph. And connect them. The first point would be at +6, +10. So if I'm here and I'm plotting that point, 6, 10 means to go to the right, 1, 2, 3, 4, 5, 6, and then up 10. So there's where that point would be. This point, -3, 10. So if I plot that, starting from the middle, the x being -3 tells me to go backwards to -3 and then up 10. So there's where that point would be. Look what you get if you connect those 2 points. A horizontal line. The reason it's horizontal is because its y's are the same. And if your y's are the same, you're going to end up with a 0 in the top, right? If you're subtracting the same number, you're going to have a 0 in the top. Okay? Now, look at number 10. So again, the answer to that one was the slope was 0. There's my x, there's my y, there's my x and y of that point. There's my one, my first point, and my second point. Look at your x's. They are the same number. Which means what's going to end up in the bottom of the slope formula now? It's going to end up, the 0 is going to end up in the bottom, right? Which is going to tell us something different about the slope. Okay, so let's do my second y, which is -4, minus my first y, which is -3. And then do your x's. My second x is 7, minus my first x is 7. So this time, look what ends up. This time your 0 is in the denominator instead of the numerator, which means that doesn't tell me the slope is 0. It tells me the slope is undefined. It doesn't even matter what's up top. Okay, if I did this in my calculator, -4 minus -3 would give me -1. But again, it doesn't matter because your denominator is 0, which automatically makes that fraction undefined, which means the slope is undefined. If, I'm not going to do it for time's sake, if I plotted these 2 points and connected them, I guess I am doing it. This point, 7, -3 would be to the right 7 and down 3. So about right there. 7, -4 would tell me to go again to the right 7 and down 4 this time. And if I connect those 2 points, what does that give me? It gives me a vertical line. So that's why vertical lines have undefined slopes, because if you use 2 points from them and plug those 2 points into the slope formula, it's going to give you the 0 in the bottom of your fraction. That's what makes it undefined. All right, number 11. Okay, this is definitely a calculator problem, but it's the same exact process. That's an X, that's a Y, they're just ugly. That's an X, and that's a Y, just decimals, but we have a calculator. There's my first point, so I give it the 1s. There's my second point, so I'll give it the 2s. So up top, I need my second Y. My second Y is 8.5. And remember, what you always put in after this first number is a minus. Then you need your first Y, which is 15.3. And then do the bottom. You need your second X, which is -11.7. Go ahead and put your minus. And your first X, which is -14.2. So again, I'm just going to use my calculator here. So let's see, what do I need to do first? 8.5 minus 15.3 gives me negative 6.8. Then my bottom one, I have negative 11.7. So negative 11.7 minus, and then negative 14.2. Gives me 2.5. So what it wants you to do is says simplify your answer. Well, what does that mean? That means just type this in your calculator and then math, enter it. So I have negative 6.8 divided by 2.5, which gives me that decimal. Okay, and it says it doesn't want the decimal answer. I don't think. Let me look. Nope. So just math, enter that to get the slope, which is negative 68 over 25. So that's the method in finding the slope of the line. If you are given 2 points on the line, you'll label them your x1 and y1, x2, y2, and then plug them into the formula. Now, another way you may be given a problem and it's asking you to find the slope is if it gives you the equation of the line. All right, maybe I'll second to write that one. So sometimes you're given the equation of the line and asked to find the slope. So if you are given the equation of the line and need to find the slope, you're going to put this equation in what's called slope-intercept form, which is y equals mx plus b. So putting an equation in slope-intercept form means getting the y by itself. That is what is by itself. You want to get the y all alone. That is what puts your equation in slope-intercept form. Once that happens, once your equation is in slope-intercept form, Then the number, we're going to call it hooked on to the x. See where this m is, and you know how that stands for slope? That's going to be the slope of the line. So let's look at one before we get to the one on the paper. Let's look at a couple. So just these are the example of three different kind of lines. All three of these equations, the y is by itself, which means it's already in slope-intercept form. Every single one of these already is in slope-intercept form. This is your y equals, that's your m right here. So that is your slope, mx plus b. So this number that's in this spot is the slope. The number hooked onto the x is the slope. This number, which is going to become very important, is the y-intercept of the line. And what does the y-intercept of a line tell you? It tells you where the line crosses through the y-axis. So the slope of this line would be 3, and it's going to cross through the y-axis at positive 7. This one, it's in slope-intercept form, right? If the y is by itself, automatically the number hooked onto x is your slope. If the y is by itself, the number hooked onto x is your slope. Even if it looks like this, y equals 3 minus 5x. It's kind of backwards, and that's why I don't just say the first number is the slope. It's the number hooked on to the x. So the slope of that one would be negative 5. So the first thing is you got to get y by itself. Now let's look at number 12. For y equals x plus 4. Y is not by itself yet, which means that's the first thing I have to do is get the y by itself. So now we're going back to chapter 2 stuff. We're using our equation solving skills. How do you get rid of a number? If I'm trying to get this y by itself, I need to get rid of that 4. And how do you get rid of numbers that are hooked on? You divide by them. If I divide this side, I've got to divide everybody on this side by 4 also. So that cancels that 4. So there's my y all by itself, which is what I'm looking for. Now, be careful here. This 4, it's not 4x, right? What is in top of this right here? It's x over 4, which means when I write the slope of this line, because that's what's going to be hooked onto the x, I need to think of there as being a 1x up there. So the number that's actually hooked onto the x here is this 1 over 4x plus 4 over 4 gives me 1. So now what you've done, since you got y by itself, is you put it in slope-intercept form, right? There's your y equals, there's your mx plus b. So the number hooked onto the x, which is the slope, is 1/4. Number 13. Negative 3y minus 4x equals 5. And it wants to know the slope. So if I'm given an equation and it wants to know the slope, first step is get y by itself. So here's the y. This is what I want to be alone. Remember, hooked on numbers go away very last. So who needs to go away first? The minus 4x needs to go away. So I will just add 4x. If I add 4x to one side of my equal sign, I have to add it to the other. So let's see what I have left. Those go away. All I have left over here is the negative 3y equals. Now be careful on the right side. Those are not like terms, right? You can't add the 4x and the 5 and put them in the same basket because they're not like terms. So these two terms, you're just going to have a 4x and a plus 5 on the right. Okay, so I just bring these down. Okay, the 4x could be behind the 5. It could say 5 plus 4x. Either way. Now, get rid of your hooked on number by dividing by it, exactly what it is. So I'm dividing by negative 3. So y equals 4 over negative 3. I just have a positive over a negative, which just makes me be a negative. 4/3 doesn't reduce, so I just have 4 over 3. X. Again, a positive number over a negative number makes me negative, and 5/3 doesn't reduce, so I just have 5/3. Y is now by itself, which means the number hooked on to X is your slope. All right, number 14 says find the slope if it exists. And it does give me an equation, but well, look at the equation. The equation is just x equals negative 2. I can't get the y by itself in this equation because there is no y. This is one of those special kind of lines. X equals a number, if there is no y involved, is automatically a vertical line. So if I want to name the slope of the vertical line, what are the slope of all vertical lines? Slope of all lines that look like that is undefined. That's the one that is the undefined slope, the vertical lines. Okay, I am going to do 3.4. There are only 6 problems, and so we may go a little tiny bit into lab, but we really need to get through this 3.4 since we missed last week. Okay, I'm going to work through all of them on the paper, and then I'm going to share some math lab work to show you some graphing skills in math lab so it doesn't wear you out. Okay, number 1. Just wants to know what the slope and y-intercept is. So I'm given the equation. And it is in slope-intercept form, right? If y is by itself, then it's in slope-intercept form. So this means this right side is your mx plus b. So it wants to know the slope and the y-intercept because this section is going to teach us how to graph using the slope and y-intercept. So let's think. The slope is the number hooked on to the x. It's not a 9, right? It's not a 9. 9's in the bottom, which means I need to think of it as a 1 up there. So the slope of this line would be 1/9. Now, the y-intercept of a line, again, every line that crosses through, there's your y-axis. This point right there would be that y-intercept. Anywhere that the line crosses the y-axis is its y-intercept. Okay? So, and it's naming this actual point, which means when you're typing in your y-intercept, you're typing in a point. A point is always an ordered pair that has an x-coordinate and a y-coordinate. If you are a y-intercept, your x-coordinate is always 0. Your y-coordinate is whatever this number is. That's your y-intercept. That's it. What's in the B position of the slope-intercept form. So this one would just simply be -5, 6 in your y spot. Now remember, you do have to type it in as an ordered pair, which means using the parentheses. Okay, so the slope is the number hooked on to x. The y-intercept is the number that doesn't have the x on it, essentially, which is -5, 6. Just put it in the y spot. Your x is always 0. So that's what you're doing on number 1. On number 2, it's going to give you the equation, and it's going to say use the slope and y-intercept to graph the line. So it gives me y equals 2x plus 5. So the steps are okay, let me write that down real quick. So I'll read out what it says. So the first thing you're going to do is put the equation in y equals mx plus b, which is the slope-intercept form, which essentially just means get y by itself. Sometimes the equation will already be like that for you. You won't have to always do that step. If the y is by itself already, you don't even have to worry about step 1. Okay? Step 2 is you're going to put a point physically right on the y-axis at the y-intercept. So remember, if you're in slope-intercept form, that's your slope. And then that number is your y-intercept. Whoops, sorry. So you're going to put a point on the y-axis at the y-intercept. The third step is you're going to count out the slope starting from that point that you just put on the y-axis and put another point where you end up. And I'll show you what that means here in a minute. And then the last step is to connect the 2 points that you have drawn. So let's look at this one. Y equals 2x plus 5, which is number 2. So the first step was to put it in slope-intercept form. This one, the y is already by itself, so I don't even have to do any work for step 1. So the second 2 steps are dealing with the slope and the y-intercept. So let's figure out what the y-intercept is and what the slope is of this line. So the y-intercept, remember, is the number that's not hooked onto the x. So it's going to cross through the y-axis at positive 5. Now, the slope is the number hooked onto the x, which is positive 2. When you are using this method to graph a line, you're going to want to see, remember the slope is the rise over the run. What happens in between points? How far do I need to rise and run? Which means if your slope is a whole number, put it over 1, because this is your rise and that is your run. So after you put this equation in this slope-intercept form, go ahead and write out what your y-intercept and your slope are. Because those are the two, that's the 2 informations that you're going to need. That's all I need to graph. So let's see, the y-intercept is positive 5. So you are going to go straight to the y-axis, which is this one up, mine's kind of slanted, mine up and down, and put a point on positive 5. That's going to be your first point of the line. So 1, 2, 3, 4, 5. And you put a point right there on the y-axis. That's the first step after you put it in slope-intercept form. Now, the second step is, or I guess the third, is to count out the slope, the rise and the run, starting from this point that you just put on the y-axis. So do your rise first. So if I'm starting from here, I need to rise up 2. Since my rise is positive 2, I'll go up 1, 2. Don't put a point there. You have to count out your rise and your run. So I rose up 2. Now I want to run to the right 1. That's where you'll put your second point. All you need to graph a line are 2 points because all you have to do is connect them. So once you put that second point, you connect it, which MathLab actually automatically does once you put your second point. So that's how you graph a line using the slope and the y-intercept. Put a point on the y-intercept. Then count out rise, run, put another point, and connect them. Okay, let's look at number 3. Y equals negative 8/3 x plus 4. So y is by itself. So I can actually skip the first step, right? I don't have to do anything to get y by itself. So here's my mx plus b. The y-intercept is the number not hooked onto the x, so it's positive 4. The slope is the number hooked onto the x, which is negative 8/3. That's all you need to know. Y-intercept and slope. So let's graph it. First things first is you go straight to the y-axis, which is this one, and put a point on it at positive 4. So 1, 2, 3, 4. Up 4, put a point. Next step, do your rise and your run. If your slope is negative, you do not want to make both moves negative, because look what that would actually do. If you made the 8 negative and the 3 negative, you'd actually be graphing a positive slope, right? Because a negative over a negative is positive. So what I would do, if you have a negative in front of your slope, you can just always make that top move the negative one, your rise move. So from this point, I need to rise actually down 8, right? Since it's negative, and then I'll run to the right 3. Starting from this red point, I will go down 1, 2, 3, 4, 5, 6, 7, 8. For the rise being down 8, and then to the right 1, 2, 3. For the run being 3, and then there's my second point, which means I can connect them. All right, let's look at number 4. (5x plus y equals negative 2). So this one, I do have to do the first step, right? Because y is not by itself. So since y isn't by itself, that's the first thing I have to do. So I need to move the 5x to the other side. So it's not hooked onto the y. I'm going to subtract it. So now I have y equals, so now the y will be by itself since I'm moving the 5x to the other side. I'm just going to bring these two down, right? I can't put them in the same basket because they're not like terms. So I'm just going to have a negative 5x minus 2. So now my equation is in slope-intercept form. So now I can pick out the y-intercept and the slope. The y-intercept is the number not hooked onto x. Be careful, it's a negative this time. So the y-intercept is negative 2. And the slope is the number hooked onto x, and it's negative 5. But remember, you need a rise and a run. So put that negative 5 over 1, and then graph it. The first thing I'm going to do is go to my y-axis and put a point at negative 2. So this time my y-intercept is down 2, right? It's on the y-axis down at negative 2. My slope is -5/1. So my rise, I'm actually going to go down again since it's negative. Down and right. So starting from this point, I need to rise down 1, 2, 3, 4, 5. Don't put a point there. Remember, you got to rise and run. I'm only running one, so I just go to the right 1 and then connect. All right, 2 more. And I know I feel like I'm kind of rushing this, but remember, you can always come back later and watch it again and pause me where you need to pause me on this. Right, x plus 7y equals 21. So y is not by itself, so I've got to worry about that first. Now remember, hooked on numbers go away last, so I need to get rid of the x first. So I'm going to subtract the x. Bring down the 7y. Equals, on the right, not in the same basket, right? One's an x and one's not. So I'm just going to have negative x plus 21. Now get rid of your hooked on by dividing everybody by 7. So there's my y equals, remember the 7 is in the bottom here, so I actually have a negative 1 on top. So I've got negative 1/7x plus 21 divided by 7 gives me plus 3. So now I know the y-intercept and the slope. Since the y is by itself, the y-intercept is positive 3. The slope is the number hooked onto x, so it's negative 1/7. First thing you're going to do is put a point on the y-axis at positive 3. And again, my slope is negative, so I'm going to go down and right. Starting from this point, I'm going to rise down 1, and then I'm going to run 1, 2, 3, 4, 5, 6, 7, and put the next point, and then connect them. All right, last one. But then I am going to share some math lab stuff too. All right, the last one doesn't give you the equation of the line. It says passing through the given point and having the given slope. All you have to know to graph a line is any point and its slope. I can graph straight from that. You know a point, any point, put a point there. It says it passes through that point. So go ahead and put a point where that is. Okay? It just so happens that it is the y-intercept that they gave us because look, if that's my x coordinate and that's my y coordinate, what is the x coordinate telling me to do? Not go left or right at all because it's 0. The y coordinate tells me to go down 4 and put a point. So you'll notice that point is on the y-axis, which means it actually is the y-intercept. They didn't tell us it was the y-intercept, but once we plotted it, it is. And remember, all y-intercepts have an x of 0. So there's a point. Now I just need to count out the rise and the run from this point. Well, if that's the slope, think of it as being over 1. There's your rise and your run. So this time, since it's positive, I'm going up 5, right 4. I mean, not 5. Up. I don't even know what I just said. Up 4, right 1. Up 1, 2, 3, 4 to the right 1, and put your next point.
Okay, so where did you get the positive 4 from?
Because it actually told me in the problem, it said, where did I get this positive 4 from?
Yes.
So it told me in the actual problem, hang on. So in the problem, it said graph the line passing through the given point and having the given slope. So it told me that it had this point. So that's why I went, the first thing I did is I just went and put a point where that was, which was right here.
Okay.
And then it told me the slope was 4. So all I did was put that 4 over a 1. So I went up 4 over 1 from here.
Okay.
Went up 4 and then over 1.
Okay.
Okay, I'm going to go to number 2 in 3.4, and this is just to show you some kind of clues on the graphing part in MathLab. Okay, so when I'm doing this, this one says y equals 2x plus 1. And I know I'm small in this thing since I'm sharing my screen. But it's already in slope-intercept form, right? It's already got the y by itself, which means the y-intercept of this problem is positive 1. The slope is the number hooked onto x, which is positive 2. And remember, you always want to see the rise and the run. So since it's a whole number, I'm going to put it over 1. So when I go to graph this, I'm going to click to enlarge. Remember, anytime you're graphing in MathLab, the very first thing you're going to have to do is tell it what shape you're about to draw. And we're always drawing lines. So just click on the line. Now, remember, the very first thing to do is to put a point on the y-intercept, which is positive 1. So actually just come over to the y-intercept and put the point. And what you see where my cursor is, it's on positive 1 on the y-axis. And put a point. Then take your fingers all the way off the keyboard. Because once you start moving the mouse around, it's going to start, the line's going to start going crazy. You can actually use, for your slope, what do you want to do? You want to go up 2 to rise 2. And then run 1. So here's what I would do. I would use the up, down, left, right arrows on your keyboard. If I want to rise to, I just hit the up arrow. Oh, I didn't do it. Oh, man, my laptop doesn't do it. My desktop at home does it, and here does it. Oh man, that takes away what I want to do. If you have a desktop, it should work. You should be able to just click the up arrow twice and then the right arrow once to go up to right one. So I guess if you have a cursor that or a mouse that you're using, from that point that I put on the one, what are you going to do? Go up 1, 2, run 1. So do you see how I did that? I went up 2 over 1, then put that second point there. And then check it. So I'll do this one too, real quick, just to give another example. Okay, so the y-intercept is already in slope-intercept form, right? It's already got the y by itself. So I'm going to put a point on the y-axis, this time at -5, right? Because the y-intercept is -5. Then the slope is -3/2. So let's put it down here. So tell it you want to be a line. Now, remember, here's your y-intercept is that -5. So you'll just come down to the -5 on the y-axis and put a point. Now, look at your slope. It's -3/2. So where does that mean I need to go now? Since my slope is negative, I'm going to go down 3, right 2. So starting from where I am, that blue circle, I'm going to go down 1, 2, 3, and then over 1, 2 to the right, and click it again. So this may take a little getting used to on Math Lab. So if you're doing a lab today, you may want to start there. That way, if you have any questions just with the graphing part in Math Lab, you can ask me while you're still here. Okay, so I'm going to go ahead